Hi, I want to go over a problem that we didn't do in class. I didn't realize that the way MyMathLab does graphing of trig functions is different than how the book does it. So I went through all the examples in the book, and I'm glad we did it because that's what you would do in real life. But the way the software works is that it wants you to find the amplitude and the phase shift, and then it graphs it for you. Okay, which is different from how working off the book works. Now, if we look at the formula the book gives us, this right here is the amplitude, right there. The absolute value of that is the amplitude. And over here, that's the phase shift. Now, what we had been working on in class is things where this is already distributed. BD. Right? So we had been working on things that look more like this, something times X plus or minus something. Okay. Now, when we're trying to find the phase shift, it actually has to have this form right here. Okay. So I need this right here to have this form. A cosine B times X minus D, and then I can read my phase shift over here. Okay. So let's look at this. Now, what I want to do is I want this X to be isolated. So I want to pull out the 10 out of this, out of this. So what we'll do, okay, is we'll go 8 cosine. Okay, I'm going to pull 10 out. All right, I'm going to factor out 10. X, right? So 10 times X is equal to 10X. But over here, in order to pull out 10, I need to divide this by 10. See, I need it to be where when I distribute this times this and this times this, that I get my original equation. So when you pull out this 10, you need to divide this by that 10. So now we get 8 cosine 10 X minus 6 over 5. Okay. So the next thing you can do is then do pattern matching. Okay. You have minus D is equal to negative 6 over 5, right? Remember, D is your phase shift. So D is equal to 6 over 5. That's your phase shift. Now, in terms of your amplitude, the amplitude is just equal to the absolute value of 8. Okay. So let's do the same thing over here, right? I want to pull out that 3. And then 3 times X, right? So this times this is equal to that, plus, okay? Now, in order to make the distribution work, that's going to be 6 divided by 3. Okay, whatever this is, I'm going to divide that 6 by it. Okay, so this times this gives me 3x. This times this gives me 6. So now let's simplify that. Like this. Okay, now we're going to compare it with this formula the book uses. So we'll go A sine B X minus D, like that. And then we'll do pattern matching. Over here, minus D is equal to 2. So D is equal to minus 2. That's my phase shift. My amplitude is equal to the absolute value of -5, which is equal to 5. So if you go to me and go, hey, Dr. Kwai, is there a quick little formula you can give me to get phase shift? And the answer is yes. Okay. Now, if you have something that looks like A cosine B X, let's just go plus D, because normally we think of things as positive, right? So in order for me to, actually, I'm sorry. Let's say I have something that looks like this. Let's not call it D. Let's call it something else. Let's call it H. Okay. So normally we have problems that look like this, right? I have some amplitude times something times X plus or minus something. Okay. And I'd like to find the phase shift. All right. What I have to do is I have to pull out that B. But before I pull it out, I have to divide this part over here by B. Okay. Now, let's remember, right, when we compare it to this up here, A cosine B X minus D. That's my phase shift. So let's make these equal. So I get minus D is equal to H over B. So D is equal to minus H over B. This is the phase shift. So if you're not given something in the form where we have 3 times and then parentheses X plus or X minus something, if you have this situation, you can just read the phase shift. It's the opposite value, whatever this is. But if they give you something that's already distributed, which is normally how you get it, you could use minus H divided by B. So over here, it would be minus 6 divided by 3, which would give you that -2. Okay, thanks. I hope that saved some of you time. Okay, thank you.